Hello, I'm Adam, and today I will show you my solution for a Zigbee mailbox monitoring device, which will be battery powered with optimized power consumption, etc. etc. First, if you haven't seen previous video where I was talking about standard ESP32C6 which can talk Zigbee about this device, please watch it because it's very nice basic start to let write programs in Arduino and let it talk Zigbee with Home Assistant and Zigbee2MQTT. And yeah, I mentioned that there is this board, the Nano ESP, and I mentioned that there is a Seed Studio variant which looks like this. And yes, it's same ESP32, and yeah, comparing sizes, my gosh, do you see that? Yeah. Okay, and yeah, Vemos C3 for example, yeah, you see that. Okay, so what's special about this tiny board? First problem that I had was well, Mailbox is all metal. In my case, it's all metal, but the back side is like blank because it's covered by wall. Yeah. But anyway, I couldn't get any Wi-Fi or Zigbee range because it was too far to my lamp in bathroom. So this tiny board has antenna output like this. So, well, to be honest, cable is too long, but yeah, whatever. So we've got a chance that it will be better. I will check just from curiosity what the antenna like this gives us, because Zigbee2MQTT can share the signal strength. And yeah, what's great about this board? Of course, we've got some I/O pins which would be very enough, but what's very important on the back, we've got battery plus and minus. That means we can just connect lithium battery to these pins and it will be natively supported. So we don't need to think about other battery chemistries like LiFePO4 and discharge it to acceptable 3.6 volt and maybe it will work, or maybe the just lithium battery cells which operates at 3 volts. Yeah, those are existing. We've got dedicated battery lithium ion pins where we connect lithium ion battery 4.2 volt fully charged. And what's interesting, if we connect the power to the USB port, the battery will be charging. So that's totally great. And they made it like very tiny board. So it's ideal for a project like this. Okay, so we are in the wiki seedstudio.com and we are on the page regarding this microcontroller board. And as we can see, we've got very nice documentation. What's most interesting for us is that this ESP32C6 board supports Zigbee. It has 512 kilobytes of SRAM and 4 megabytes of flash. And next, dimensions and of course power consumptions. So in deep sleep model we've got 15 microamps consumption, but I will check that. I hope for like around milliamps, we'll see, which gives us a pretty long battery operation time. Next, we've got schematics, we've got pinouts. And there we've got pretty important information. If we want to use an external antenna, we need to set the XIAO 14 to high. And there is an example in Arduino to do that, which is, wow, great. Next, some random informations how to do that. yeah, we need to add ESP32 boards, etc., etc. Wow, I'm amazed that they got very nice documentation. Even we can see there is some kind of hello world flashing, and yeah, there is a LED. There is a battery usage section which shows how the LED behaves when we are charging the battery, which it's good to have. And there is a section which we are reading battery voltage. Yes, we are doing voltage divider with 200k resistors, so it will be a 1:2 ratio configuration. That means we'll read, for example, if battery will be 4 volts, we'll read 2 volts, and the Arduino will know the correct battery voltage. So if the battery voltage will be low, we'll get a pop-up, which is great. Yeah, we've got chances to make a pretty nice and useful device, and for very cheap, and yeah, we'll see how it will perform. Next, we've got even deep sleep examples with external wake up. That's exactly what we need. So deep sleep is the deepest sleep that's available, and external wake up means that we've got some ESP32C6 GPIO pins which can wake up ESP in some patterns. Like we've got 7 pins, and it's up to us which pin will be used for wake up, and we can, for example, if 2 pins are pulled too high, that means for a specific wake up reason. Yeah, of course we'll use 1 pin because yeah, we don't need more. Next we've got with timer. Of course we can wake up ESP32 periodically, and deep sleep, and there are even official wake up examples. That's good to know. Yeah, and some resources. Yeah, so guys, well, it's great. I mean, wow, I'm impressed, and it's cheap, like $5 or $4 per this board. Regarding hardware, that's how it looks like. Let me unconnect the battery. Yes, I decided to load it with 10,000 milliamp hour battery. I use two 21700 cells. Well, I expect very long battery life. I think even over a year. So I will just connect it, install and forget about it. And of course I will insulate it, but yeah, it's I'm before calibrating, that's why. And of course we've got magnet that I just got from the Aquara sensor. There is my reed switch, which was pretty expensive, like $4, but good thing about that is it can detect magnet within 9 millimeters, so that's very nice distance. Yeah, and there we've got the ESP32, which got connected following. We've got battery connected to minus and battery plus, so that's normal. Then we've got 220 kilo ohm resistor, which is connected to the analog pin A0. Same resistor is connected to the ground, so we are creating there a voltage divider which should be about 1:2 ratio. You can use 200,000, 300,000, it doesn't matter, because those will consume a little bit of energy, but it's about few microamps, so yeah. There we've got 10,000 ohms resistor, which is pulling down the pin from the sensor, and we've got capacitor for stabilizing the analog readings. Yeah, and yeah, generally that's it. How does it work? At this moment it's connected, and of course I will connect the battery and I will install it some like this, and this will be about next to the flap. And the read is connected in normally closed, so contacts there are closed unless I connect the magnet, and if I remove, those are closing. Yeah, that's how it works. One more thing, as you can see, I haven't got antenna installed. Why? Well, in my case, I have no idea if it's fake ESP32 or I just don't know. But with external antenna, and when because to use external antenna you have to turn one GPIO down and another GPIO up. Yeah, and I was doing it on at the very beginning of the setup, and I saw that if I will go down with a battery voltage to like under 3.7 volts, it's not possible to operate Arduino. I mean, ESP is crashing. So unfortunately I had to remove external antenna, which generally it doesn't matter. I mean, Zigbee devices are connecting to each other, which is closer, so if I will go away, it anyway will connect to the nearest, for example, Philips Hue bulb, so it doesn't really matter. And I tested it, because in my case we've got metal casing. Fortunately, range is okay, I'm connecting to Zigbee network and everything is fine. Without the antenna, it's not needed. Okay, 2 words about power consumption. In deep sleep I've got about 50-60 microamps, which is a little bit more than it was shown in the datasheet, but whatever, it's anyway very, very low value. And there we've got the code, and what this code is doing. This code is sending every 1 hour battery state, which it got read, just to act as a keep alive signal, because I read somewhere that there are some limitations, and to don't mark this device as dead, it should mark somehow it's alive within 64 minutes. So every 1 hour I'm sending battery percentage and everything is fine. Yeah. And unfortunately, due to, I have no idea, maybe some limitations of the libraries or something, sending battery was the only one thing that was working properly. I mean, when we wake up, we measure the battery and we send the contact state, and I couldn't send the contact state. And additionally, I had a problem if I set contact to open, then I would need to set it to closed, so I will have to send 2 messages and of course battery power. So instead of sending 3 signals, I went with sending only 1 battery state, and the rule is every 1 hour I'm sending heartbeat signal, meaning real battery percentage. And if the trigger and if the read got triggered, that means I've got mail. So we got woke up from GPIO pin, from the sensor, and I'm sending 1% value as a unique value to the Zigbee2MQTT. And when I will receive this 1% value, I will create a notification that I've got a mail. Yeah, it won't go naturally to that low percent, because I saw that in about 3.4 volts is the lower limit of voltage, under which ESP32 is not stable. So I've got from 4.2 volts to 3.4 volts. This is my operating voltage range. Yeah. So like, let's say 40%. Okay, now let's talk about the Arduino code. We've got constants where we've got endpoint number 10, which is for the Zigbee standard endpoint, a battery pin where we've got connected battery plus, a pin which is waking us, wake up mask. Generally ESP can wake up on some patterns on GPIO pins, and there we just set up a bit mask for the external one wake up source. We've got debugging toggles. We can set up to report battery heartbeat instead of 1 hour, for example, like 60 seconds. And we can set up debug logging true, and we can send random battery value. That means I will have changing value all the time, every cent. Yeah, so that means I'm correctly sending and receiving the message. That was for the debug purpose. It's worth to set it like to 1 minute or even 10 seconds and set random battery value to true, and check if you put similar device into metal casing, you still got range and you are still sending the values. Yeah, that's why I created that. Then we are creating Zigbee contact switch object, which yeah, as I said, we are using only the battery voltage. So we've got some helper functions to measure the voltage, and there is a ratio, the resistor divider ratio. In this case is 1 to 2, and I will calibrate it to have exactly pretty nice accuracy of voltage reading, because of course I have to do it at least once. We've got a helper function which converts volts to percent. Yeah, just standard mapping. Then we've got report battery. Yeah, so generally those in this function we just simply report send the Zigbee messages using those two lines, send value and send report, and that's it. And for logging purposes we just read what's the battery percentage. Yes. Next we've got detecting if the interview was done, because the first run looks like we need to do an interview with Zigbee2MQTT, and we have to configure one option, so only once. So I'm detecting if interview was done, and yeah, there is a setter, getter. I'm saving it in a non-volatile memory. And there we've got setup function, which is starting every wake up. That's how it works. Like the loop function is empty in this approach. And yeah, we are setting serial, we are setting pins, some yeah, basic options are set, like the name and model. That's how it is. It appears in Zigbee2MQTT. We are setting power source battery, so the Zigbee2MQTT knows that we are battery powered, and we are adding endpoint. Yeah, and yeah, some another basic functions. Then we've got wake up detection, and if wake up reason, it's later. Then we've got first boot. If it's first boot, we are trying to connect to network, and we are waiting for Zigbee2MQTT. Then we are giving 30 seconds for manual config in Zigbee2MQTT. I'll show you how the process looks like. After everything is done, it goes to sleep. Then, if we got woke up by X1, so the GPIO pin, we've got mail event, so we are reporting battery 1%. If we've got ESP wake up timer, so we woke up in 1 hour, we are setting the heartbeat, the real battery percentage, yeah? And yeah, that's how it looks like. This is about if random battery flag was set, so we are doing random ±5. That's very enough to have different value every message, and we are reporting battery. Then for safety, if something will crash, we'll just anyway fall back to sleep. I saw that we can crash it when something overlaps, and I've got crash error that ESP was already awake. So yeah, there was some kind of a crash, but it's very rare, so yeah, I don't see a problem. When it was happening when I just was setting quick triggers, maybe that was the case. And we are reloading the wake up triggers, and generally that's it. How to flash it? We need to go to tools, and what settings do we need to set? Erase all flash before sketch upload. This thing erases the memory of the first interview was completed. So if we do enable, every time we flash sketch, we'll have to do interview, because the board will do interview. And to be honest, I recommend this because in rare cases when I was changing very little thing, it's okay to make it disabled and keep device in a network, so you don't need to pair it. But I had problems with that. I mean, some messages were like lost, something was cached. So anyway, I recommend setting it to enabled. Flash frequency, that doesn't matter. Flash mode doesn't matter. Flash size, we don't got choice anywhere, doesn't matter. Partition scheme, this thing is important. We need to set it to Zigbee 4 megabytes with SPI FFS. That's still fine. CPU frequency, I will change it back to 160 because that was default and it doesn't affect the power consumption in any way, so yeah. Next we've got Zigbee mode. We have to set it to end device, and generally that's it. And how to flash it, because as you know, try to upload the code in a correct moment. So I'll press upload, then the rule is that if this bar moves right, I will connect my ESP. Yes, really. Okay, and now connect. I'm connecting the ESP, it got connected. I hope it won't go to sleep. I'm flashing, and when we'll see that percentages are moving, we have to allow devices to join, and shortly after flashing, the ESP will join the network. As you can see, interview started and interview finished. So we've got now 30 seconds to go to reporting, to select endpoint 10, to select cluster power configuration, battery percentage remaining attribute, change it to 1, so at least one value in change. And yeah, now we wait. And now after the timer 30 seconds got finished, we are after interview, we are after setting this setting. Every 10 seconds in my debug case, we are sending the battery voltage, which is there. And what next? We can see it in the logs, and there we've got within 10 seconds this message. I will trigger the magnets, and as you can see, we've got battery 1, and I've got the pop-up that I've got mail. Simple as that. Okay, so that's how the automated template look like. You will have to change, of course, your topic and your device and your phone, so you will get notifications on your phone. And that's how it looks like. So when I just remove magnet, I will get pop-up. And yeah, that's how it looks like. Thanks for watching. Please leave a comment and hit the subscribe button. Bye.